open up is the correct word. Take out the homework from Monday. I know Monday was a little while ago because we had a nice day off yesterday, but the worksheet was called independent and dependent events. And I just want to review one of each type of event with you. And then I wanted to look at the chart that's underneath with you. And then, as I said, we're going to go through a few questions in the notes pertaining to finding more probabilities, just more examples of probabilities of independent and dependent events. So to refresh from Monday, the first group of problems, 1 through 12, you were asked to determine if the events were independent or dependent. Independent means the first event doesn't change, doesn't affect, doesn't influence anything that's going on in the second event. Dependent means whatever you do the first time, the first event is going to change, impact the second event. So if we look at the last two problems on the front of this page, number 11 says a numbered ball from 1 to 40 is selected from a bin. So think you're playing bingo. And in bingo, there's that like circle thing and you crank the wheel and the balls all kind of spin around. And a number is selected from 1 to 40. And then when you play bingo, that numbered ball is set down after it's called out and another one is chosen. So one of them is selected and then a second numbered ball is chosen from the remaining balls in the bin. And the question is that independent or dependent? So does taking out the first one change the number that is remaining? Yes. So Haley, if that changes, is it independent or dependent? Right, that is dependent. And you could say that the number has changed, or the number remaining, maybe we'll say has changed. We started with 40. If you take one out, now you have 39. So I don't have the same number that I started with, therefore it's dependent. There has been a change. The first pulling of the ball has changed my options for the second time I go. Number 12 is very similar, except now we have numbers 1 to 52. This one says a numbered ball from 1 to 52 is selected from the bin, but then there's a key word. It says it has been replaced. So we're not playing bingo if it's replaced. So the ball was replaced and then a second numbered ball is selected from the bin. So Emma, is that independent or dependent? So yeah, this one's independent. And it's independent because you are replacing the ball back into the bin. So the number did not change. And that is a key word to look for. If it says replace, you're starting with the same number. So if I give you a deck of cards and I say pull out a number and look at it and then put it back in the deck still has 52 cards if you're replacing it back in the deck. So that would be independent versus dependent. Was there a change? Do I have one less than what I started with? Then it's dependent. Independent, if you place it back in the stack, then the same number is there from what you started with. Looking down at the next page, going to the very bottom, this table here shows the number of endangered or threatened species in the United States. And we have mammals, birds, reptiles, amphibians, and then other species. So endangered and threatened species. And there's a couple of different probability questions that we want to kind of talk about. the first thing that we suggest you doing is to find a total, and whether you label it or not is up to you. But we need to get totals so that we have numbers to work with. Jason, do you have the totals going down vertically in the column? Just what do you have for the endangered? Say it again. 390. And then what do you have for threatened? $129. So make sure you're getting a total. When we add those two numbers together, that's 519. So that's our total. That's the number of endangered and threatened animals. So 519 total different types of endangered and threatened species in the United States. So the first question says, what's the probability that a listed animal of these threatened endangered species is a bird? So we want to find the probability that one of the animals is a bird. Haley, how many birds are either endangered or threatened? 91. So you're looking at the birds, 77 are endangered, 14 are threatened. So that would be 91. And then that's out of the total of 519. So 91 out of 519. That's the probability that an animal listed is a bird. The second question says, what's the probability that a listed animal is endangered? So now we want to find the probability that we have an endangered species. And Jason added all of those up for us. And if we go down to the bottom total here, we have 390. So that would be 390 endangered species out of 519. So those are two general probability questions. Number 19 and 20 is where it changes a little bit. This is where we have that condition. What's the probability that an endangered animal is a reptile? So that specifies the type of animal that we're looking at. And this is that condition problem. So we're looking for reptiles given that an animal is endangered. So this is how I would write my probability. Specifically, the group of animals that we're looking at are endangered animals. We want the reptiles that are in that group. So if we look in our little chart, the reptiles that are endangered. So here's our endangered list. There are 14 reptiles that are endangered out of 390 endangered animals. So the number on the top are the 14 reptiles. The number on the bottom would be all of the endangered animals. Haley, could you place that in your calculator and reduce that? You said 195. That's what I thought you said. I just wanted to make sure. So that is called conditional probability. We're given the condition that we're looking at endangered animals. The last one says, what's the probability that a threatened animal is an amphibian? So again, I'm going to write this out so we can kind of see what it should look like. So the threatened animal is now the specific animal that we're looking for. And it says is an amphibian. So amphibian goes first. And the specific group are the threatened animals. So we're going to the threatened group now, down that column. TJ, how many amphibians are in the threatened group? And how many total threatened animals are there? 129. Questions? So when you see that wording, this condition that's given tells us the specific total we're looking for. So no longer the total of 519, but instead my total is out of the threatened animals of 129, or the endangered animals of 390. Any questions on those? So you should have most of this worksheet done if you were in class or you watched the video, because Mr. King did the entire previous problem with you. And then we went through a good number of the independent versus dependent event problems together as well. So make sure that you submit this, watch the video, which will give you the other answers if you want to take a look at that, or you can finish the worksheet on your own. So what I'd like you to do is to take out your notes. One last day. This is the last day of the note packet that we are going to use and look at. So final day of notes. Take out those notes, page 28. This is it. Last time that you have to pull out that packet. And again, it's page 28. So whether you're at home, it's slide 28, or you're in school, it's page 28. So we will need a calculator again today. We're going to be multiplying fractions. The final two little pieces of information, finding the probability of independent and dependent events. So if A and B are independent, then the probability that both A and B can occur. So this is two things happening, one thing and the other, can be found by taking the probability of A and the probability of B. You're going to take the probability of A and multiply it with the probability of B. So and means to multiply your two events together, which is kind of like the multiplication counting principle that we did. The second part says if they're dependent events, if A and B are dependent, remember that means the first event is changing the second event, then the probability of A and B, still and, is taking the probability of A times the probability of B and then given A. Remember that is the given little bar. So we will be multiplying our probabilities together today. And I'm going to show you how the first one is a little different from the second one. And I think you'll find these to be pretty straightforward once we work through a problem or two. So example 3, a bag of marbles, 14 yellow, 10 red, 12 blue marbles. Suppose you randomly select 2 marbles. Find the probability that the first is yellow and then the second is not yellow. So before we look at that, let's get a total. So we have 15 yellow, 10 red, and 12 blue. So let's find a total first. So we know how many marbles we're working with. So Haley, 15 plus 10 plus 12 is 37. That's our total. The question says, find the probability that the first marble is yellow. So I'm going to put the probability of yellow. And the second is not yellow. So I want the probability of getting a yellow and then not a yellow. So we're going to find the probability of having a yellow and then the probability of not having a yellow. It says you replace the first marble before picking the second. All right, Emma, how many yellow marbles are there in our bag? 15. So the probability of getting a yellow marble would be 15 out of 37. So you pull the marble out, you look at it, you replace it back in your bag. So that means the number of marbles, I started with 37, but I replaced the marble back in the bag. So I still have 37 marbles in the bag. Emma, how many marbles are not yellow? So I have the probability of a yellow marble, the probability of the marble that is not yellow. So probability of one, probability of the other, and then you multiply them together. Now, when you multiply fractions, you need to multiply the numbers on top. So I don't want you to put the fraction in your calculator. I want you to take 15 times 22. Oh, Haley, what is 15 times 22? 830. And then on the bottom, you're going to multiply 37 times 37. And Haley, that number is? Right. So when you're multiplying fractions, I want you to go across the top and across the bottom. So 830 over 1,869. And then I'm pretty sure that doesn't simplify. Emma? 330? She may have said that and I just didn't hear. Thanks, Emma. So 330 and 1,869. And I don't think that simplifies. 1869 doesn't look like a number that's going to simplify down. So that's finding the probability of getting a yellow and not a yellow. Now, the second one says you do not replace the marble before selecting. So it's the same exact question. Find the probability of getting a yellow and not a yellow marble. So the probability of getting a yellow marble hasn't changed. It's 15 out of 37. Jason, what do you think happens if you take the marble out and you don't replace it? How many marbles now do we have to choose from? 36. So here's the difference. If you don't replace it, your bag has one less. So the second probability is now 22 out of 36. That part has changed because I have one less marble in the bag. I took out a yellow one and now I have 36 remaining. So we still have on the top 330. Remember, you're multiplying across the top. Jason, if you multiply across the bottom, we're taking 37 times 36. And does that reduce? questions? So we're multiplying, but we're changing what's happening. All right. I would like you to scroll down and we're going to look at example 4. Talking about pencils. Your teacher passes around a box with 10 red pencils, 8 pink pencils, and 13 green pencils. So we're looking at 10, 8, and 13. So let's get the total first. So Emma, 10, 8, and 13, 31. If you and 2 people in your group are the first 3 students to select a pencil, what's the probability that all 3 of you select a pink pencil? So let's make this a nice pink here. This looks like a nice pink. So we're looking at a pink pencil. So we want to find the probability that you get a pink pencil. The second person in your group gets a pink pencil. And the third person in your group gets a pink pencil. So I want 1 pink pencil, another pink pencil, and then a third pink pencil. TJ, how many pink pencils are in my box? Out of how many total pencils? 31. All right, so I don't have a box, but I have a little jar here with pencils in it. TJ, you select a pink pencil from my jar. And now Haley is going to select a pink pencil. How many pink pencils are left, TJ, if you picked one out? How many total pencils are left if you took one out? 30. All right, Haley. Now it's going to go to Jason. You got your pink pencil. How many pink pencils are left from my jar if you got a pink pencil and TJ got a pink pencil? And how many total pencils are left? 29. That's how dependent events work. So you're taking out a pink pencil, and because it's the same color, I now have 1 less pink pencil and also 1 less pencil in my jar. And then when it comes to Jason, he's going to have 6 to choose from out of the 29. So when you multiply, remember you're going across the whole top and across the whole bottom. So I don't want you to put those fractions in your calculator. I want you to multiply the 3 numbers on top together and the 3 numbers on the bottom together. So Jason, 8 times 7 times 6. 336. And then 31 times 30 times 29. And will your calculator reduce that for you? Okay, nice job. Questions? Any questions on reducing the fraction? Use that math fraction button on your calculator. All right, why don't we go to the homework on Google Classroom? We'll see if we can do a couple of examples together from the homework assignment. So we're looking at section 10.8 practice worksheet. And we're going to go down and look at the middle group of problems, 5, 6, and 7. So 5, 6, and 7 is a 2-part question. So the first part says, find the probability of drawing the given card from a standard deck of cards. Part A is with replacement. So you take the card out, you place it back in the pile. Part B is without replacement. So you take it out and you don't put it back in the pile. The first one says find the probability of getting a club and then a diamond. Haley, do you remember how many clubs are in a deck of cards? Yeah, 13 out of 52. You replace the card back in the pile. Haley, how many diamonds are in a deck of cards? 13 out of 52. So you take the club out, you put it back in, and then you get a diamond. You take it out, and you still have 13 out of 52 cards. So I know 13 is 169. Haley, do you know what 52 times 52 is? I'm pretty sure this does reduce. Yeah, 1/16? Yeah. All right, so this is what happens when we replace the card. We're going to do the same problem again, but you're not going to replace the card. So the probability of getting a club is still 13 out of 52. The probability of getting a diamond is 13 because there are 13 diamonds, except you didn't replace the card. So now you only have 51 cards remaining. So it's going to be 13 and then out of 51. So that's the big difference in the problem. So it's still 169 on the top. Jason, how about 52 times 51? And that reduces to Ray over 204. So let's look at the second one. The probability of getting a jack and then a 7. Emma, do you remember how many jacks are in a deck of cards? Or how many 7s? 4 7s. There are also 4 jacks. So that gives us 4 times 4 is 16 out of 2,704. And Emma, when you get a chance, you can say what that reduces to. You say 1. The next one, without replacement, I still have 4 jacks. I still have 4 sevens, but now I have 51 cards. So that's 16 out of 2,652. And I think that's 4 out of 663. All right, the last one like this. You want to get 3 kings. So there are 4 kings in a deck of cards. I want to get 3 kings. So the first king is 4 out of 52. The second king is 4 out of 52. The third king is 4 out of 52. And then the other option is not to replace it. So this is like the pencil problem. So I take a king out, I have 3 left. I take a king out, I have 2 left. So here would be the last problem with the kings. And you can see the difference between replacing versus not replacing. So 4 out of 52, 4 out of 52, 4 out of 52. But then once you don't replace it, you're losing a card each time. So there's still 5 minutes, 4 minutes remaining. There are 14 total problems. The last 4 problems, you're just saying, is it dependent or independent? So you're not doing any calculations for those. And the first 4 problems, you're going to look at that bus chart and make sure you get a total for that first group of problems. Always need to know the total. Anytime you have a chart, add those values together to get yourself a total. So I added the numbers in the chart for you if you want to look at those numbers. So you're going to answer the questions underneath pertaining to that chart. So you have one chart question. There's another question dealing with marbles. And then the last question is just, is it independent versus dependent? So tomorrow we'll just work through the review worksheet together. Go over a couple of these questions, work through the review worksheet. Hopefully we have the review worksheet done when we're in class. We just do it all together as a class, and then you can submit it at the end of the class. And then quiz on Friday.